This is energy lesson number 4, and in this lesson we're going to be learning about electrical energy. So our lesson intention for this lesson is to understand what is electrical energy and how electricity moves, and our success criteria are the things that you need to ask yourself at the end of the lesson. Are you able to do these things? So, the success criteria are: I can describe electrical energy as energy of moving charges. I can identify that electrical energy moves through a circuit. I can name the main parts of a circuit. And I can use symbols to interpret electrical circuits. Okay, so these are the things that we'll be looking at today, and these are the things you should be able to do by the end of the lesson. Okay, so first of all, what is electrical energy? Okay, electrical energy is probably one of the most useful forms of energy we have. So remember, energy is the ability to do work. They allow us to do things. And we know that, we use electrical energy a lot because all around our house we have, these things like power points. We have all of these things. And electrical energy is really useful because it can be easily changed or transformed to other types of energy. So for example, in our houses we'll have, these power points. We plug something in and, we can change electrical energy into light energy to power up our computer monitors, or, we can use electricity to change it to sound and light energy for our televisions, or even plugging in a light bulb into a power point will change electrical energy into light energy. So electrical energy is really, really useful. It's really, really versatile. Okay, but what exactly is it? Electrical energy is energy that comes from moving negative charges. So electrical energy is energy that comes from moving charges. Okay, it's actually moving negative charges to be exact. So basically, particles that you've learned about this in material science, that everything is made up of particles. Some particles are just normal, they have no charge. Some particles are negative and some particles are positive. So I'm going to just represent negative charges with a circle with a minus symbol in between them. So basically, electricity is energy that comes from negative charges moving from one place to another. So if you can imagine, if all of these charges are moving from here to here, okay, all these negative charges, they will create electrical energy. So at a year 8 level, that's all you really need to know about electrical energy in terms of its definition, is that electrical energy is energy that comes from moving negative charges. Okay, keep in mind that it is negative charges. Okay, so let's look at how does electrical energy move? How does it go from one place to another? In the previous slide, we said that electrical energy comes from moving negative charges. So how does those moving negative charges go from one place to another? Okay, so for example, we've got here a connection. We've got here a battery. We've got some wires here. We've got a light bulb and some wires connecting it back to the battery. So let's just label it first so that we're all clear what everything is. So this is a battery. This is a light bulb. And this is a wire. Okay, so basically this is called a circuit. A circuit is where electricity can move from one place to another. That's how electricity moves. It has to move through a circuit. And this picture here is an example of a circuit because it allows electricity to flow from the battery along the wire to the light bulb, and the light bulb changes the electrical energy into light energy, and then it allows the moving negative charges, the electricity, to move back to the battery, and then again and again and again. So a circuit is like a loop that connects all the different parts that needs the electricity. And in a circuit, there's three main parts, and it's shown here in this diagram. Firstly, you've got a source of power. So you've got a power source. In this case, it is a battery, but you can have a power point, or anything else that can supply you with electricity. So here we've got, like a battery as a power source. You also need a pathway for the electricity to flow. Okay, so this is our pathway, the wire is our path. And then you need something called a load. So a load is what changes electrical energy into something else. So in this situation, the load is a light bulb because it changes electrical energy into light energy. Instead of a light bulb, you can have a radio, because a radio is the load because it changes electrical energy into sound energy. You can have a fan instead of the light bulb, because then it will be a load still because it changes electrical energy into moving energy or kinetic energy. Okay, so basically a circuit needs to have all of these three things: a power source, a path, and a load, and everything needs to be connected. Okay, if there is one part that is not connected, then electricity can no longer flow in that circuit. Everything needs to be connected. Okay, so for example here, this picture shows another picture of a circuit, and we know it's a circuit because it has a load. In this case, it is still a light bulb, changing electrical energy into light energy. We've got a power source. Okay, again, this is a battery. And we've got a path as well. So those are three main components. But this time, we've also got an extra part, which is called a switch. Now, a switch is something that we put in to switch the circuit on and off. So it's like in a normal house, you wouldn't want your light to be on all the time. Okay, but because the way that the circuits are wired, it needs to be always connected. So the way that you can only turn the light off is to break that path, is to actually tear the wire apart. But we don't want to do that. Otherwise our houses will all have to be repairing our wires and stuff. We don't want to cut the wire into pieces so that it breaks the circuit. What we do is we put a switch in to break the circuit. So if it's on, it means that the path is unbroken, it is continuous, and the electricity can flow. If I switch this to off, that will mean that this switch has broken the pathway. So electricity will be here, and it gets to here, and it will have nowhere else to go. Okay, so it can't go around in circles, and therefore electricity can't flow, and this light will be off. So it's really important to know that the circuit needs to be continuous and unbroken for electricity to flow. Okay, now all the diagrams we've looked at, so for example, if we just look at this this picture here and this picture here, these are very common electrical circuit pictures. So here we've got a battery, we've got two light globes, and we've got a switch that switches it on and off. Over here is the same thing. We've got a battery, we've got two light globes, some wires, and a switch that turns it on and off. Okay, so these two, are pretty nice electrical circuit pictures. People can look at them, you can look at them, and basically know how the circuit is set up. Now, to draw pictures like this is actually quite complex. Okay, you have to spend a lot of time drawing the pictures. Not everyone is a good drawer. So, if you set up a circuit and you're not a very good drawer, you might end up drawing something that no one else can understand. Okay, and as you saw in all the previous pictures, a battery can, a picture of a battery can be drawn in like 10 different ways. A picture of a light bulb can look really different from one person to another. Now, in science, we like to make things simple so that, if you're not a good drawer, you can still draw an electric circuit, and we want to make sure that all the symbols are the same for every single scientist so that there's no confusion. And this is where electrical circuit diagrams comes in. So if you look at the bottom here, this is an example of an electrical circuit diagram for this circuit, and this diagram is the diagram for this circuit. So as you can see, instead of drawing like a fancy battery, we just drawn a long line and a short line. Instead of drawing a fancy light globe, we just drawn like, like a little half loop with a circle around it. Same thing here. Instead of drawing this light globe, we've drawn like a little half loop and a circle around it. And instead of drawing a fancy switch, we just went like, here a line with a dot, a line and a dot. So it's actually like a very easy way of looking at it. Okay, so same thing here. All these parts, this is the battery, that's this light globe, this is this light globe, and this is this switch. So the reason why we like to draw diagrams as scientists is that it is much more simpler, it is faster, it is clear. So if you're a bad drawer, you can still draw a circuit, and everyone uses the same symbols. Okay, so everyone will draw a battery like this, everyone will draw a light globe like this, so that it is absolutely clear and consistent and the same for all scientists. Okay, so these are the standard diagram symbols of the electrical circuit. Okay, there are some parts of a circuit that has like multiple symbols. Okay, so let's just go through each of them. So this is a switch, and if the little line here is up and is not joined to this switch, it means that the switch is off because it's a broken pathway. Okay, if I want to draw a closed switch, it will be a line with a circle, line, circle. It will be a closed switch. The one that I just drew will be a circuit that is on. Okay, this is called a cell, okay, or a 1.5 volt battery. This will be a battery as well. So in the year 8 level, like it's okay to sort of, use both of these ones, but later on in later years, this is known as a cell. So it's 1.5 volts, and this is like, more volts. Now, lamps, they're a bit different. So some people like to draw lamps this way, and other people, which I actually prefer, like to draw the lamp like this, like the one you saw earlier. So a little loop with a circle around it. This is also known as a lamp. It doesn't matter whether you choose to use this one, so a circle with an X, or this one, as long as you just choose one and you use it. So please do not mix this one and this one together. We've also got a voltmeter, which is really simple. It's a V with a circle around it. A voltmeter is something we use to measure the voltage of the circuit. An ammeter is we use it to measure the current. With these two components, you don't really need to know them in year 8. We'll explore more of it in year 9. But then, since they're here, we might as well just, tell you what they are. Okay, so same with these ones here. You don't really need to know them at a year 8 level either. We've got a resistor, a variable resistor, which means a resistor that can change different resistance, and we've also got a motor, which is like that's something that's spinning. Okay, so a motor is very simple as well, an M with a circle in it. But at a year 8 level, you only really be using this one, this one, this one, and this one. Okay, so switch, cell, battery, and lamp. Okay, and also for wires, this is a line. This will be a wire. Okay, so now let's look at some different examples of drawing electrical circuits. Okay, so I'm going to go through maybe 3 or 4 examples here, and with each example there will be a picture, okay, like a fancy picture of an electrical circuit, and I've just added the symbols down here so we can refer to when we draw an electrical circuit diagram equivalent of the picture. Okay, so when you draw an electric circuit diagram, you look at the circuit and you look at, okay, what have we got? So in this circuit, it's really basic. We've got a battery, we've got one wire, we've got a lamp, we've got another wire that connects it to the battery. Okay, so let's draw this. And if you are doing this, you need to draw it with a pencil and a ruler. Okay, now on my app here on my iPad doesn't have a ruler, so I'm going to draw as straight as possible. But for you drawing at home, you need to be using a ruler. Okay, so first of all, let's draw the battery. So the battery, I can either use the cell symbol, okay, or the battery symbol. So just to keep it simple, I'm going to use the cell symbol. So I'm going to go a long line and a short line, okay, with like 2 wires sticking out like this. make sure that your wire joins exactly. Okay, so there's no gaps in your diagram. And then I'm going to draw this wire, okay, this blue wire that connects the battery to the lamp. Okay, so there's another wire, and again make sure everything is connected. And now I'm getting to the globe. Okay, I'm getting to the globe here. So I like the other symbol of the globe. I don't like drawing the X with the circle. I like this version of the lamp. So I'm going to go like this, lamp, like that, circle. Okay, now because I'm drawing the iPad, it's not straight, okay, but make sure everything is connected. And now I'm going to draw this wire back, connecting the lamp to the battery. So I'm going to go like this and like this. Okay, remember at home you need to be using a ruler and the pencil. Okay, now notice that the circuit diagram is very rectangular and boxy. Okay, so that's what we do. Like, we don't draw them curved, we draw them in nice straight square rectangular manner. Okay, so this is a really simple example of a circuit. Let's have a look at another one. So for this example, it's a bit more complicated. Again, we still got a battery. We've got a switch this time now, and notice that the switch is down. That means that this circuit is on because electricity can flow all the way around. If this switch was up, okay, it means that it will just be here, and then the electricity can't flow between the gap. Okay, so this switch is on, this switch is closed. So we've got switch, we've got 1, 2, 3 lamps. Okay, so let's start with the battery again. And again, I'm going to use the cell symbol for my battery. So I'm going to go long line, short line, line, line. Okay, so that's my battery done. Next thing I need to do is to draw my draw my switch. So I'm going to do like this, and because it's a closed switch, it's going to be a circle, flat line across, another circle to indicate that it is closed. And then next will be the first light globe like this. Okay, and then the second light globe, and then the third light globe, and then connecting everything back together. Okay, I like to draw the little bumps first, and then I draw the circle around all the light globes. Okay, easy. So again, remember, you at home, use a ruler, use a pencil, and make sure there's no gaps in the circuit, because this circuit diagram here, this picture, does not have gaps. Your circuit diagram shouldn't have gaps either. And keep it boxy, keep it rectangular. Alright, let's look at another example. So this time it is really similar. We've got a battery, okay, we've got a switch, we've got 2 light globes. Now this time, because this battery seems quite large, it seems to have a lot of volts, so I'm going to use this battery symbol instead, just to mix it up a little bit. Okay, so I'm going to do long line, short line, dash, dash, dash. Okay, long line, short line, and then do the wires coming out of it. Okay, and then we're going to go this way. I've got 1 light globe, 2 light globe, and I think that switch is on because the light globes are glowing. So again, circle, and the switch is on, so this line should be flat. Okay, and then line. Now, I'm just going to rub out a little bit of the circuit. So I'm just going to rub that out. Okay, so make everything nice, okay? And I'm going to draw the circles over the globes now. Okay, and there we have it. Okay, like this. If this same circuit, if these light globes, right, if these light globes were not glowing and they were dark, which means that this switch will be off, what it will look like is it will look like this. Dash, dash, dash. Okay, again, 1 light globe, 2 light globe. It will be like this instead. Okay, the switch will be here, it will be opened. Okay, so that means that as the things move around, it is not a complete continuous path. And again, I need to complete my light globe symbols with a circle around the light globes. Okay, let's have a look at another example. This time, this has an amp meter in it. Okay, so this is an amp meter. An amp meter is this something, so it's a piece of equipment that we use to measure how much current is going through the electrical circuit. So this time we've got a battery, a small battery, an amp meter, and a light globe. So the way we will do it is, if we look at our symbols, here I'm going to use the cell symbol, I'm going to use the lamp symbol, but the other one that I like, the little bump symbol, and I'm going to use the amp meter symbol. Okay, so let's see how it goes. So first of all, let's draw our cell, so long line, short line, and that connects up to an amp meter. So an amp meter is a circle with an A in it, and then connects up to a light globe, and it all connects up back to the battery cell, and draw a circle around the bump for the light globe. And that's it. Okay, very simple. Let's have a look at another one. This time, you can't really tell, but this one is a voltmeter. So a voltmeter is like an amp meter, but instead it is a piece of equipment that you measure how much voltage or how many volts the circuit has. Okay, and this one is a little bit tricky. We've got a battery source here, a battery. Okay, we've got a light globe, and then we've got it connected to a voltmeter like this. So I'm going to use this symbol for the battery, the cell. I'm going to use the lamp symbol, but the bumpy version, and then I am going to use the voltmeter symbol, okay, which is a circle with a V. So let's start. So for this one, okay, long line, short line for the battery. Okay, it is connected to a light globe like this. Okay, circle around the light globe, and then what you've got here is, if you have a look at the voltmeter, okay, see how it's got two wires connected to the light globe, just like the battery. There's two wires connecting it, so that's why my one is like this over here. So if you have a look, it will be line, V with a circle, wire, and wire like that. Okay, so that will be our circuit symbol for the voltmeter. So that's the end of this lesson for electrical energy, what it is and how it flows. So if you think back to the success criteria, you need to be able to actually say that electrical energy comes from the movement of negative charges. You need to know that electrical energy moves from one place to another with a circuit, okay, in a circuit, which is a continuous pathway that has a power source, a load, and a path for electricity to flow. And you need to know how to use these symbols to draw and interpret electrical diagrams. And this is the end of the electrical energy lesson.